Welcome to a new mini-series. This series is going to focus on more advanced optimization techniques for use in estimation of structural models. Up until now, we've mainly been using the Optim package in Julia to do basic likelihood or moment-based estimation. But there's a lot more optimizers out there, and while likelihood-based and moment-based optimization tends to be the bread and butter of econometrics, that's not to say that these other optimization algorithms could not be useful to you as some other part of a structural model. So in today's video, we'll mainly talk about a Julia package called JUMP that has an array of features, including some of the ones that we've already used in Optim. And the goal is to just familiarize yourself with what's out there. And in other videos in this series, we'll talk about some other advanced optimization techniques that can come in handy if you have an involved structural model that you're trying to estimate. As I said, we've been using Julia's Optim package almost exclusively so far. And this is basically what you would use if you're trying to perform nonlinear optimization. And that's completely in line with likelihood or minimum distance estimation, where we're just trying to do a very simple, unconstrained, nonlinear estimation. But there's other types of optimizers out there, and they may not be as applicable to econometric applications, but they could still be useful to have in your general arsenal of tools. So we'll go through maybe some other applications that they could be useful for, and then if you've been exposed to this, maybe you can find some use for these other tools. So what is there besides nonlinear optimization? Well, there's something called linear programming. There's mixed integer programming. This would be a case where you don't have a continuous choice variable like a beta coefficient. You instead have a choice variable that takes on integer values or categories. There's semidefinite programming. There's convex optimization. There's constrained nonlinear optimization, which is what we're going to spend a lot of time on in the next couple of videos. And basically, this package called JUMP in Julia is a one-stop interface that allows you to seamlessly change the type of optimization you're doing. And that can be very useful in terms of conserving code. You don't have to write code specific to a particular optimizer and so on. And these other algorithms in JUMP are used quite a bit, primarily in what's called operations research. So this would be things like I'm trying to come up with optimal bus routes or other public transit scheduling. I thought it was nice to put in bus routes here because we talked about the Rust bus engine problem in the past. Other public infrastructure like power grid architecture, solving budget constraint problems where there's linearity in the utility function. So these are all valuable real-world uses. And then maybe not as valuable is solving Sudoku puzzles, but it can be used to do that as well. And then again, the main feature of JUMP is that it can interface nicely with a bunch of different optimizers. And so you don't have to change your code if you want to use a different optimizer or a different algorithm. So this reduction in code switching can be a time saver and a headache saver. Now that we have this overview of JUMP, in the next video, I'd like to demonstrate how to use it to estimate some of the econometric objective functions and econometric models that we've encountered so far. And we'll compare and contrast JUMP with Optim for some known and simple problems. And then later on, we'll illustrate how to do constraints, which can be a useful tool to have when estimating these complicated structural models.